more water than we need per year in storage. And that is replenished by the rain. So why should we have shortage of water? But we have shortage of water. And then we start pumping as close as possible at home, because then we don't have to transport it. But if we pump more than nature provides on the mountainside, at the other side here in Cebu and in many of your places, I'm sure it will be the same when you are living along the coast, the sea has plenty of water. And when you pump more than the mountain supply, then the sea is generous enough to supply all what you are pumping. The only problem is that we don't like to drink seawater. We learn what we can tap from our wells, but that means again and again and again you have to write your numbers down so that you know what it was 30 years ago. Because some of these changes are very slow. There is no that other threat in the whole world. We are talking about climate change. What will that be for this location? The scientists don't know yet what the climate change will carry. We definitely don't know what it will be for this island. Will we get more rain or will we get less rain? Will the temperature go up or down? We may get more clouds than before, and then the temperature goes a little bit down. No big changes. We don't know. What can we do then about it? Yeah, we cannot stop it. If there is a climate change, then we here cannot stop it. Maybe mankind can stop it, by all and everybody doing a little bit. So we have eventually to prepare ourselves for the consequences. But if we don't know in which way the development will go, how can we know? Again, observe. We have been in our outfit observing here the area for the last 30 years. So we have data, and we may be able at this moment to see if there is a trend in these data. Is there more rain coming, is there less rain coming, or whatever. So we really have to study and not be afraid of writing down what we are doing today. Maybe that 10 years from now they say, you're crazy, you shouldn't have done it. That's the risk. If you don't write it down, they never will, they don't declare you crazy, you are crazy. If you don't want to see the reality, so we are at that point. And then we can put things together, what we have along the sea. We consume groundwater. It is coming on the screen too, so that you can read it there too. We actually denude watersheds. We complain about dry rivers in the dry season. And we scream about flash floods in the rainy season. I think that everybody recognizes himself. And in the city, and it's not only for Cebu, we destroy natural watersheds by taking sand and gravel from the wrong places. The easy places, of course, but they are sometimes the wrong places. And we contaminate our potable water. Right? In this city, but not only in this city, by effluent of the septic tanks. And we are pumping alongside the septic tanks. That's ugly, but it is a fact. What is nature doing in the denuded watersheds? It releases water faster. Denuded, that means less soil, de facto. Yeah, we see no trees and we call it denuded. But the fact is then that the soil is growing. So there is less storage. It releases water as long as it rains. And thus there is also less water to resupply the groundwater. And then along the coast, nature resupplies eventually the demand of our overpumping by salt water. Are we now going to blame nature for our mistakes? Or are we trying to learn what we can do and what we should not do? I think the conclusion is clear. We will have to try to do better than what we have been doing until now.
Now, Father has practically mentioned writing down numbers. And what I'm about to say is also about writing down numbers. That's what the University of San Carlos Water Resources Center has been doing for the last 30 or more years. So my slides will be about Water Resources Center at the University of San Carlos. But we will go faster because we have very little time left. Is it okay if I sit down? Anyway, it's not much difference. Okay, let's go back to the year 1975. Something happened in Cebu City. Shouts from the business sector, industries, institutions, and households became clear and unanimous. Their wells have become salty. And so Father Herman van Engelen, SVD of the USC, was asked for solutions. The pooling of water experts from here and abroad, particularly the Netherlands, followed. The activities that were pursued were enormous and somehow, as a result, bonded together a group, the Water Resources Center of the University of San Carlos. So the name here is a little bit longer. Foundation Incorporated has been added. What is WRC? It is a research unit, but it's also a consulting group. Its key staff are hydrologists, geohydrologists, engineers, and planners. It is a SEC-registered foundation and thus has its own board of trustees. Aside from the main board of trustees of the university, WRC has its own board of trustees. In the university, WRC is formally linked to the Office of Research here, and then most closely professionally linked also to the Department of Civil Engineering, because most of the works at WRC is civil engineering in nature. WRC's energy is directed towards, first, a better understanding of water and water resources. That's education. That's what we're here for in this particular room. We work for access to water of right quantity and quality. Not just that, also timing. That when you open your faucets, water flows, not just a drop. Our work is also geared toward proper disposal or reuse of water. And of course, the big term, sustainable use of water. What is our dream? Most corporations call this a vision, that there is adequate water for everyone's need today. And according to Father, he places a figure 100 years after. And mine is like 1 generation after. Now at WRC, since we started with a problem about hydrology, that was saltwater intrusion, the core interest is of course hydrology and water resources. And in such core, the data, information, knowledge obtained find very interesting applications in urban drainage, river basin management, GIS, data management, institutional development and strengthening, and most especially, water supply, because everybody needs water. In the hydrology and water resources sphere, WRC engages in a solid amount of data collection and measurements related to surface water, the water that we see, and groundwater, the water that we do not see. WRC monitors rainfall, evapotranspiration through evaporation. We have in Central Cebu, we have about 40 rainfall monitoring stations. Besides Pag-asa, we are also doing monitoring. And we measure river flow, runoff, groundwater levels. We measure salinity in 150 or about such number in the coastal wells of Central Cebu. I'd like to direct your attention to 4 or so basic parameters of water balance, in which the basic, I should say easy to measure parameters come handy. They are the rainfall, evaporation, surface runoff. This is the water that you see running from your rivers to the ocean. And of course, the groundwater flow, which runs also in meters per day, meter per day, as in contrast to the surface runoff, which runs meter per second. So I direct your attention to those 4. So when we have the water balance, we see that in must be equal to out. If the in is less than the out, then we have a problem. There is inequilibrium. So we have the only in parameter, which is rainfall. Others have their snow, others have hail, but we have here rainfall. Then the out parameters are plenty or more than 1. One out parameter is transpiration, evaporation, and plant transpiration. Another one is the runoff. What is this? Is it a piece of cake? No, this is a diagram of a simple watershed. In the watershed, rain falls in, evapotranspiration occurs, then the watershed loses water. Then another one, the runoff, where watershed also loses water to the sea. Then you have the groundwater flow, an outflow, but very, very slow. That's what we use in our wells. I mean, this is what we intercept when we drill wells. And then, of course, because we have rocks, we have the soil in the watershed intact, we expect storage to be maintained there. And every year, if we do the water balance, we will see through simple computations that storage may be negative from January 1 to December 31, or it may be positive, depending on the rainfall occurrence in that year.